we've seen how to calculate values, but now let's find out how we can define values from graphing. So here we have three graphs. So find the values of the following by graphing. There are our graphs. Do remember, your answer is going to be only as good as the graph. So these are terrible graphs, I do realize. So our answer is going to be somewhat fair. So let's find out though. A, f at 2. Which graph are we looking at? If it's f at 2, well, we have f of x equals 3 to the x, g of x equals 1/3 times 3 to the x, h of x equals 2/3 raised to the x. Well, it has to be the first one, right? F of x. So let's look at the first graph, f of x, top left. And let's see if we know the x value, because that's where the 2 is right now, the place where the x normally is. So if x equals 2, then y would be, that's original form of stating this, agreed? This is the old way of stating this. So we're looking for the y value, in other words. So if we visualize x at 2, there's a dash for x at 2. We trace it back up until we meet our graph there and sort of trace it back into our graph. We have a somewhat of a big range there because of how rough the sketch is. But this gives us a rough visual. It gives us somewhere between 8 point something and 9, right? Or somewhere between 7 and 9, I would say. But best guess in this case, roughly 9. So let's say, based on a rough sketch, rough graph, rough estimate, f at 2 equals 9. And there's our answer. Once again, as close as you can get it, based on your visual point. G of x is our next question for B. G of x, where's G of x? Hey, that's the second graph at the top, right? So the top right graph. G of x equals 1/3 times 3 to the x. And we're looking for when G of x equals 6. Is that the x or the y value that we know? Well, if it was the x, we wouldn't have an x shown there. So it means it has to be the y. So it's like saying if y equals 6, then what is the x value? And our statement is, well, let's see where the y value of 6 is. There it is roughly. 1, 2, 3, 4, 1. Notice that there's a dash right where our graph crosses. Be aware of that, okay? Pretty close to where our dash crosses, there's a dash. So 1, 2, 3, 4, 5, 6. There's roughly 6 with our dash line. And then let's trace it back down into our x-axis, which gives us roughly 2.5, I would say. So g of 1/3 times 3, agreed, gives us roughly 2.5 for x. Once again, this is just a rough visual for us. You're welcome to correct me if there's any of them that are wrong. Be aware of that. So there we go, g of 2.5 equals 6. And D, h of x. H of x, not the top two graph, right? That means it's the bottom graph. Bottom left, bottom right side graph. Only one we have at the bottom. So h of x equals 1. That's like saying the y value is the one we know. So if y equals 1, then x equals what? So looking at the y value of 1, be careful there, you might miss it. There is a dash right once again where our graph crosses the y-axis. In other words, in this case, we're looking at the y value of 1 being our intercept. There's a dot to represent it. So that means our answer is h at 0 equals 1. So the x value is 0. The y value is 1. That's what was given to us. So that is our full answer. H at 0 equals 1. The question and answer all in one. E, h at -1. That's like saying we now know the x value is -1. Agreed? So if x equals -1, then the y value equals, and once again, we're looking at the bottom graph. So at -1 for x, we should get roughly 1.5. And there it is. A rough visual for you. Notice I didn't make it a dash in this case since we already have a dot. I want to avoid mixing the dot. So roughly at x equals -1, you follow it up until you meet the graph. Follow it to the right and you get roughly 1.5. 1.3 to 1.5 would be acceptable. Just as a rough idea. So there are our answers for this case. From the graph, we can actually visualize our answers or estimate our answers in many cases.